Hi, welcome to DBMS Database Management System video lecturing. In this video, we are going to learn the topic weak entity type. The weak entity type, basically it is also an entity type where, so when we will call it as a weak entity type means the entity which does not have a key attribute of their own, such entity types we are calling it as a weak entity types. The definition of weak entity type can be defined as the entity which does not have a key attributes of its own. Those entity types we are calling it as a weak entity types. Means, so for example, when we are talking about the different set of entity types, we are segregating different set of entity types into two categories. One is the strong entity type and second one is weak entity type. So the word strong entity type, when we will call it as a strong entity means, so these kind of entity types have a key attributes of its own. So those entity types we are calling it as a strong entity type. Weak entity type means the entity type which does not have a key attributes of its own. Those entity types we are calling it as a weak entity type. That is a major difference between uh, strong entity and weak entity. For example, so if we have a student, okay, the student will have a student entity type will have a student ID, SID, then S name will be there, and then third attribute is age. Okay, age is the one more attribute. So then, if I'm talking about the weak entity type, for example, dependent is there. Dependent. It is dependent is one of the weak entity type where this weak entity type will be represented by using a double rectangles. That is this is the representation where weak entities will be represented in the ER diagram by using a double rectangle boxes where we have a so dependent name, that is D name, and as well as so D relation, that is dependent relationship. So these are the two type of the attribute which is we are having for dependent. So here the dependent is an example for the weak entity type. The strong entity type example is student. Why? Because we have a key attribute in the student entity type, that is SID is the primary key attribute, where dependent, it is a weak entity type which does not have a key attribute of its own, therefore we are calling it as a weak entity type. So in order to identify the entities of weak, so what we are doing means, so we are referring with the, we are connecting to the strong entity type. So means, for example, when I want to extract the value of the or attribute value of the D name and dependent relationship, so then I need to refer strong entity type. Means I have to connect this weak entity to a strong entity. When I will connect a weak entity to strong entity, then I can retrieve the value of weak entity types. So therefore, the entity type that identifying our owner entity, when we will call it as identifying our owner entity, is nothing but so owner entity or identifying relationship. Identifying Okay, so when to which we are calling it as owner entity means the entity that is strong entity where we are connecting to a weak entity to retrieve the attribute, that strong entity we are calling it as a owner entity. Okay, so then the relationship which is existed in between these two, strong entity and weak entity type, that relationship we are calling it as a identifying a relationship, that we are calling it as identifying relationship. This identifying relationship, which will be represented by using a ER notation, that is double diamond symbol. So this identifying relationship will be represented by using a double diamond symbol in the entity relationship diagram. That is what we are calling it as a identifying relationship of the weak entity type. This weak entity type symbolically that will be represented by using a double rectangle boxes, which is identifying relationship by double diamond boxes. Okay, this is about your weak entity type. I'll repeat the weak entity. So when the definition of weak entity can be defined as the entity which does not have a key attributes of its own, such entity type we are calling it as a weak entity. The entity type which have a key attributes of its own, those entity types we are calling it as a strong entity type. The weak entity will be represented by using a double rectangle boxes where dependent is one of the weak entity type. This is an example for the weak entity which is having a dependent name and as well as dependent relationship are the two attributes where it does not include any key attribute. But student is one more example for the strong entity type. So this entity is having a SID, S name and age, where SID is the primary key of this student entity type. Therefore, that is an example for the strong entity. So here when we want to retrieve the value of a weak entity type, then I required a relationship. Through that relationship, I can extract the value of that is weak entity type 2. So that is nothing but that dependent needs to be have a relationship. That relationship type we are calling it as an identifying relationship. That identifying relationship will be represented by using a double rectangle boxes. Then strong entity, through this strong entity we can extract the value of the dependent attribute, dependent entity type attributes by using this identifying relationship. So both the attributes entity types, that is strong entity type and weak entity types, are participating in this relationship type, that is identifying relationship type. Then when it is strong entity is participating in the identifying relationship, then that strong entity we are calling it as a owner entity. Then weak entity is also participating in this relationship type. To extract those value, we are using the primary key attribute of the owner entity type and as well as one of the attribute of the dependent will be, helps to extract the value from the weak entity type. Let us see how these two entity types, strong entity and weak entity type, can be mapped by using a relationship diagram. So let us consider first strong entity type diagram, that is employee entity type, and as well as weak entity type, that is dependent. So both are having a relationship. The relationship type name is has. Employee has dependent. Okay, so like that, whenever we are referring from the strong entity to a relationship type, we can read it from employee has dependents. Okay, so here you can see these are all employee set: employee E1, E2, E3, E4, okay, E5. These are the set of employees here. Relationship set where we are mapping the strong entity type and as well as weak entity type. So this dot will indicates that weak entity type set, that is dependent 1, dependent 2, dependent 3 and so on. So now the first, employee E1 has a dependent, then he has to participate in this relationship type, that is has. So for example, the D1 is dependent on employee E1, then this D1 is also participating in this relationship type. So that is employee E1 is also has a dependence, then that is D2, then that will be represented by using like this. And so D3 is also have a dependent on employee E2, then employee E2 is participating in this relationship, then D3 will be the dependent. Like, so each and every, so dependents are totally depending on the employees. So that is employee set E. For example, let us consider the employee table. We are having a employee ID, the employee name, and then employee department number and employee salary. So here, so this employee name, employee ID, employee department number and salaries are there. So by using the one of the attribute from the strong entity type, we are relating or we are referencing, so or else we are extracting the value of dependents. For example, in the dependent we are having a two attributes, like there is no any such attribute value, we can make it as a key attribute. So therefore we are calling it as a weak entity type. The entity type which does not have a key attributes of its own, we are calling it as a weak entity type. So therefore, so for example, employee ID 1, employee ID 2, employee ID 3 is there, name is XYZ, PQR and as well as LMN. Okay, similarly employee department 1 and 2, he is getting a salary of 20,000 and here 15,000 salary and here 20,000 of salary. So this particular table, so in this particular table, whenever a dependent, we want to extract the information of the dependent, so then we need a such a attribute where, so it totally depends on by using that primary key attribute, we are going to extracting the dependents by using that employee ID. Here employee ID is the so key attribute in this particular table. By using employee ID, so we are going to extracting the weak entity type attribute values. So along with the weak entity type attribute name we are using, so then so automatically we are extracting the weak entity type. So now by this diagram, so we have to identify the degree of a relationship type and as well as we have to identify the cardinality ratio. So the cardinality ratio is nothing but maximum participation constraint. So then participation is nothing but minimum. The participation is nothing but minimum always. So we need to check the minimum of this particular entity set which are participating in this relationship type. So for example, you can see here the maximum each entity set is participating in this relationship type is more than 2 here. So for example, E1 is having a 2 dependents, that is D1 and D2. E2 is having a D3, only 1. That is maximum participation from the entity set employee is N. Here, so dependents are there, all the dependents are participating in this relationship type, only minimum 1, that is nothing but maximum number of times is 1. So therefore here this is N indicates that the particular entity type of E1, so maximum number of participating in this relationship type has, and similarly so each dependent sets are there, D1, D2, D3, so those are all participating in this relationship type maximum number of times, that is maximum number of time they can participate only one time, therefore it is N and it is 1. Now the minimum participation, here in the employee entity set there are some of the employees are there, they may not have any dependents, they may not have a dependents, then so in that case we can representing it as by using a 0. But when I am talking about the dependents, so however this particular dependent tables are there, those dependent tables are totally dependent on the each and every employees, or means every employees. Like for example, D1 and D2 totally depending on the employee E1, D3 is totally dependent on the E2, means how many entity sets are there, like D1, D2, D3, D4, D5. So if their values are there in this table, means they are all dependent on any one of the employees in this employee set. So therefore, so this the minimum minimum participation of this particular dependent is 1. Okay, so now this degree of this relationship type is 2. Now so we will see by using an entity relationship diagram how we can represent by using a singly line representation and double line representation. So now this is the strong entity type, therefore it is employee set. Here it is identifying relationship, therefore it is represented by using a double diamond boxes, and here double rectangle boxes will be representing to identify the weak entity type, that is dependent, and here it is has. Okay, so now we need to represent this, so by using a single line and double line representation. So I told, so how many dependents are there in this dependent entity set? All are dependent on any one of the employee in the employee set. Therefore it is total participation constraint. Total participation constraint, that is represented by using a double line. But here, so some of the employees, they may not have a dependents. Therefore that is partial participation. That partial participation is represented by using a single line representation. Now, so here you can see the cardinality ratio. When I am representing here, if you are representing here n, here if you are representing it as a 1, so we won't get a correct meaning. So while writing, you have to write here n and as well as here 1, means so all the dependents are means all the dependents of this dependent entity set, so they are totally depending on the at least one of the employee in the employee table, that is employee set. So therefore, so for here it is representing it as a n, and here it is representing it as a 1. This is what representation of single line and double line representation of entity relationship diagram. The same thing if you are representing it by using a min max representation, then representation will be in this form. This is minimum, maximum, here also minimum, maximum. The identifying relationship is has, so this is the dependent, and here it is employee. So minimum participation is 0, maximum is n, here minimum is 1 and here maximum is 1. This is the min max representation of the weak entity type relationship type. Okay, always this dependent table entity sets are there, they are all total participating in this relationship type. Always remember, so this dependent entity type sets are there. How many entity types are there in this entity set? All are total participation. Therefore here we are representing by using a doubly line representation. This is the total participation. Always weak entity types are total participating in this relationship type. This is about your weak entity type and as well as the representation of the weak entity